Welcome to a deep dive into the world of material stress analysts. Getting ready for an interview, that means you're on the path to analyzing things like bridges and even airplanes.
To make sure they can handle all those forces, it's like detective work, but for machines.
Right. And to help us break it all down, we've got RoleCatcher's Material Stress Analyst Career Guide and Interview Guide. We'll even peek into their AI platform.
All to help you nail that interview.
Exactly. And I gotta say, I was looking at RoleCatcher's Career Guide, and this field's in high demand.
It really is. Makes all this prep work even more valuable.
Okay, let's dive into some sample interview questions. And not just give the answers, but how to really impress.
Exactly. Strategies, not just facts.
All right, first one. Describe your experience in conducting stress analysis on materials. Sounds straightforward, but what's the hidden meaning here?
Proof. They want proof you understand the core principles of stress analysis.
Okay, so it's not just listing projects I've done.
Right. It's showing you can use what you know to solve problems, think critically.
Got it. So how do I make my answer stand out?
Think back to projects, studies, even work, where you analyzed material stress. What software did you use? What were the tough parts?
Oh, and did I use any special techniques? RoleCatcher mentioned finite element analysis is big in this role.
They'll want specifics, how you applied it, what you learned.
So like if I used FEA to analyze stress on a turbine blade, I should mention the software. The challenge is what the analysis revealed.
Exactly. And structure is key. Use the STAR method. Situation, task, action, result. Helps them follow along.
Makes sense. Oh, and even mentioning relevant coursework.
Absolutely. Shows your foundation, even without tons of work experience.
Okay, taking notes. Now, what follow-up questions might they throw my way?
They could ask you to dive deeper into a specific project, especially if it's related to their work.
Oh, or about my experience with different types of stress analysis.
Like static versus dynamic loading.
Which leads us perfectly to question 2. What is your experience with finite element analysis, FEA? We touched on it, but how do I take it to the next level?
Hands-on experience. Specific projects using FEA. Explain the goals, the analysis you did, the hurdles.
Show my been in the trenches.
Right. Were there issues setting up the model, interpreting results? They want skills, not just theory.
This is where RoleCatcher's AI could be amazing. They analyze job descriptions and suggest skills to highlight.
True. They pinpoint what hiring managers are looking for.
Yeah.
It's about tailoring your answers to hit the bullseye.
Incredible. Okay, back to FEA. What specifics should I include?
Software proficiency. Name the packages, specific modules you're comfortable with.
Okay, got it.
Then, types of FEA analyses. Linear or nonlinear, static or dynamic. Show the breadth of your experience.
Makes sense.
And lastly, problem solving. Describe a tough project, how you tackled it. Let them see you in action.
So if I used ANSYS to analyze a bridge under dynamic loading, I mentioned that specific software and analysis type.
Exactly.
Then I could talk about simplifying a complex model to make it run efficiently.
And how you validated the simplified model's accuracy.
Right. Show them I'm thinking critically.
Now, for follow-ups, be ready for meshing techniques, boundary conditions, validation methods.
Like you'd compare different software, dig deeper into a project.
Exactly. Be prepared to go deep.
Definitely brushing up on those FEA concepts. Ready for question 3?
Hit me with it.
All right. What is your experience in performing fatigue analysis on materials? This one's fascinating to me. It's not just about instant braking, but withstanding repeated use, right?
You got it. Fatigue analysis is huge in aerospace, automotive, just where a lot of material stress analysts end up, according to RoleCatcher.
Makes sense. So the interviewer is gauging my understanding how I apply it practically.
Exactly. They want to see you can walk the walk.
So what kind of experience should I bring up here?
Projects where you assessed fatigue life of a component, a structure. What testing methods did you use? Specific software.
Oh, and the challenges, my approach, the results?
Did you factor in stress concentrations?
Uh-huh.
Surface finish? Those impact fatigue life significantly.
Okay, let's say I analyze the fatigue life of a wind turbine blade. I can talk about simulating cyclical loading from wind, the effects of UV exposure, environmental factors.
Perfect. Now some key points. First, fatigue terminology, stress cycles, SN curves, fatigue limit. Demonstrate that knowledge.
Got it.
Then, specific testing methods, rotating bending tests, axial fatigue tests.
So I've got practical skills.
And lastly, showcase your analytical skills, how you interpret fatigue test data, make recommendations.
This is so helpful for structuring my thoughts. Now, follow-up questions. What could they ask to dig deeper?
Different fatigue failure mechanisms,
Yeah.
crack initiation and propagation, or how factors like stress concentration affect fatigue life.
Okay, need to be ready to get specific about those fatigue concepts. Before we move on, something interesting from RoleCatcher. They said material stress analysts don't always work in labs, right?
Right. Their career guide says lab work is important, but a lot of analysts work in design, manufacturing,
Collaborating with other engineers?
to develop and improve products.
That's good to know. Shows the career's versatility. Okay, next question.
Let's hear it.
Question 4. Can you explain the difference between static and dynamic loading? This one feels a bit theoretical.
It is, but fundamental. They're testing your mechanics knowledge. Think of static loading like a book on a table. Constant force.
Oh, I get it.
Dynamic loading, forces that change over time, a tree swaying in the wind.
So static is constant, dynamic means movement, things changing.
Exactly, and they affect materials differently. Static might cause permanent deformation, dynamic, fatigue, failure.
Okay, starting to make sense. How do I explain this best?
Clear definitions, simple terms, relevant examples. Then how each loading type affects the materials, mentioning stress, strain, and fatigue.
Oh, and tie it back to my own experience.
Have you analyzed structures under both types of loading?
I could talk about analyzing a bookshelf under static loading from the weight of books versus dynamic loading on a bike frame from bumps and vibrations.
Perfect example. Illustrates the difference, shows practical understanding.
Great. Now, potential follow-ups.
Specific types of dynamic loading, like cyclical or impact loading, or material properties relevant to each, like yield strength, fatigue limit.
Got it. Need to be ready for those specifics. On to question 5.
Yeah, let's go.
What is your experience in conducting failure analysis on materials? Now, this sounds intense.
It can be. It's like detective work, figuring out why something broke. They want to see if you can investigate and give recommendations.
So not just knowing how things break, but preventing it from happening again.
Right. That's the key here.
What experiences should I be highlighting?
Projects where you had to find the root cause of a failure. What tests did you use? Did you examine the fracture surface? Chemical analysis?
Oh, and this is where I can mention specific techniques, like fractography or
Yeah,
spectroscopy.
Exactly. And don't forget the conclusions, the recommendations to prevent future failures.
Like if I found a manufacturing defect, I'd recommend changes to the process.
Exactly. Show them you're not just analyzing, you're solving.
Okay, so let's say a pressure vessel failed. I could talk about using different techniques to figure out it was a weld defect. Then, recommending better welding procedures.
Excellent. Now, key points. Different failure analysis techniques, the tools you used, microscopes, spectrometers, testing machines.
Got it.
Then your analytical problem-solving skills. Detailed project, how you pinpointed the root cause. Showcase your detective work.
Makes sense.
Finally, communication. Explain your findings clearly, written or spoken.
Okay, this is really helpful. What about follow-up questions? How will they test my knowledge?
Specific failure mechanisms. Fatigue, corrosion, creep. Or they could ask about material properties, design flaws, manufacturing defects.
Okay, I'll be ready to dive deep into that world. Before we go on, how can RoleCatcher's AI personalize interview feedback?
It's pretty cool. They analyze your practice responses and give insights on your content, delivery, even body language, all tailored to the job you're applying for.
Wow, personalized tips on how to improve. That's amazing. Okay, ready for question 6.
All right, let's hear it.
Can you explain the concept of stress concentration? Sounds like it could get technical.
It can, but it's a fundamental concept. They want to hear you explain it clearly and relate it to real stuff. Imagine a sheet of paper. You pull on the ends evenly, stress is distributed equally. Punch a hole, pull, the stress builds up around the hole.
So stress concentration is like a buildup of stress, usually around holes, sharp corners, changes in shape.
You got it. And those areas are more likely to crack or fail.
That's why analysts need to identify them and fix them in designs.
Exactly. It's about preventing problems before they happen.
So how do I explain this during the interview?
Define stress concentration in simple terms. Use an analogy like the paper one. Then give real-world examples. Bolt holes, fillets, notches.
Okay, got it.
Finally, talk about ways to reduce stress concentrations. Increasing the radius of fillets using stress-relieving features.
So I could talk about how a sharp corner on a bracket can cause it to fail, and how increasing the radius of that corner makes it more durable.
Exactly. A perfect example.
Great. What about potential follow-ups?
The relationship between stress concentration and fatigue life, or how material properties affect stress concentration,
Oh,
or methods for calculating stress concentration factors using FEA to analyze it.
got it. Need to be ready for those specifics. Before we move on, RoleCatcher's Career Guide talked about certifications in this field.
They did. Certifications like the Certified Stress Analyst, CSA, aren't always required, but they show expertise, commitment to your career.
A real advantage.
Absolutely, can set you apart.
Good to know. Okay, next question.
Hit me.
Question 7. What is your experience in selecting materials for specific applications? This feels like a mix of technical knowledge and practical experience.
You're absolutely right. The right material is critical for a product to work well, last long, and be affordable. They're seeing if you can think it through and make informed decisions.
So it's not just about knowing the properties, but how they affect performance in specific applications.
Exactly. A great material for a plane wing might be terrible for a bridge support.
Right. It's about context.
Think about projects where you chose materials based on design requirements. What were the main considerations? Strength, weight, corrosion resistance, cost.
And RoleCatcher's Career Guide was interesting here. They said material stress analysts work in all sorts of industries, each with its own needs.
Right. Aerospace, automotive, medical, construction.
So if I have experience in one, I should highlight that.
Absolutely. Shows versatility. Now let's structure your answer. First, key material properties. Strength, stiffness, toughness, corrosion resistance, thermal conductivity.
Okay, I could start by explaining those and give an example. Like choosing a material for a prosthetic leg. It needs to be light but strong, biocompatible, and fatigue resistant.
Perfect. Outline the requirements, the materials considered, and why you made your final choice.
Got it.
And mention any experience with material selection software or databases. Shows you can research and compare options.
Okay, I'm getting the hang of this.
Yeah.
Now, what about those follow-up questions? How will they test my knowledge?
They might ask about specific material trade-offs, strength versus weight, cost versus performance,
Oh.
or your experience with material testing standards, how to incorporate sustainability.
Makes sense. I'll definitely review all that before the interview. Ready for question 8?
Fire away.
All right, can you explain the difference between elastic and plastic deformation? Back to basics.
Fundamental stuff. They're testing your grasp of material science. Think of a spring. You stretch it a little, let go, it goes back to normal. Elastic deformation.
It bounces back.
Now, bend a paperclip too far, it stays bent. That's plastic deformation. Permanent change.
Okay, so elastic's temporary, plastic is permanent.
And they affect materials differently. Elastic is reversible, usually harmless. Plastic can weaken the material, make it more likely to fail.
Got it. How do I explain this during the interview?
Clear definitions, simple language, use analogies like the spring and paperclip.
Okay, I like those.
Explain the differences. Highlight reversibility versus permanent change. Bring in material properties like yield strength, elastic modulus.
Oh, and related to projects I've worked on.
Yes. Have you considered both types of deformation in your work?
I could talk about analyzing a car bumper that's designed to deform elastically upon impact to absorb energy.
Perfect. Shows you understand the practical side of it.
Great. Now what about follow-ups?
Material properties. Yield strength, tensile strength, ductility. Or they might discuss factors that influence the shift from elastic to plastic behavior.
Like temperature.
Exactly. Temperature or strain rate.
Okay, so I need to be ready to go into those details. Before we go on, I've got to mention RoleCatcher's AI-powered CV and cover letter builder.
It's pretty amazing. Their AI analyzes job descriptions and suggests skills, keywords to include.
It's like having a pro resume writer on your side.
It really helps tailor your application for each specific role.
Love it. Okay, back to the questions. Ready for number 9?
Absolutely. What is it?
What is your experience in conducting thermal stress analysis on materials? Things are heating up.
This one is interesting. It's all about how temperature changes affect materials. Imagine a bridge on a hot day. The metal expands, creating stress. At night, it cools, contracts, more stress. This can lead to fatigue, even failure.
I never thought of it like that.
Yeah.
So can I evaluate how materials perform when temperatures change?
That's exactly what they want to know. Think about projects where you considered temperature effects.
Okay, I'm thinking.
Did you use software for thermal stress analysis? Did you do experiments to measure things like thermal expansion? Did you make design changes to mitigate thermal stress?
Let's say I designed a heat shield for a spacecraft re-entering the atmosphere.
Yeah.
I could talk about simulating the extreme heat, choosing materials with the right thermal properties, and designing the shape to minimize stress.
A perfect example. Now, key points. First, showcase your knowledge of the concepts. Thermal expansion, conductivity, thermal shock. Use the right terms.
Got it.
Then describe your experience with analysis techniques, software simulations, physical experiments. Show them what you've done.
Okay, makes sense.
Finally, problem solving. How have you approached thermal stress challenges? What solutions did you come up with?
So I need to connect theory with practical examples.
Exactly. Show them you can solve real problems.
This structure is really helpful. What about follow-up questions? What could they ask?
They could ask about specific failure mechanisms, thermal fatigue, thermal shock, creep, or how material properties like thermal expansion coefficient affect things.
Okay, got it. I'll be ready to bring the heat. Before we move on, I saw on RoleCatcher's platform that you can connect directly with employers.
That's right. By opting in, you let potential employers find you. It's a great way to expand your options, put yourself out there.
Amazing. Okay, question 10, bring it on.
Let's do it.
Can you explain the difference between ultimate strength and yield strength? Back to the core concepts.
Another fundamental one. Imagine pulling a metal bar. It stretches, snaps back when you let go, but pull hard enough, it deforms permanently. That's yield strength, the limit of elastic behavior.
Like when it stops bouncing back?
Exactly. Now, keep pulling. It'll stretch, deform until it breaks. Ultimate strength, the maximum stress before failure.
So yield strength is about permanent deformation. Ultimate strength is about breaking point.
You got it. They have different uses in design. Yield strength for things that shouldn't deform, like bridges. Ultimate strength for things that must withstand high loads before breaking, like airplane parts.
Makes sense. How should I explain this?
Define them simply. Maybe use the metal bar analogy. Explain the key differences. Then how they're measured and their role in design.
I could talk about designing a crane hook. It needs ultimate strength to lift heavy loads, but it also can't deform permanently, so yield strength matters too.
Perfect. You're getting the hang of this. Now, follow-up questions. Other mechanical properties related to strength. Factors that affect strength, like temperature or how the material is processed.
Okay, lots to think about. This deep dive's been so helpful. Before we wrap up this first part, I want to learn more about how RoleCatcher's AI can tailor my answers to job descriptions. Can you tell me more?
Absolutely. Their AI analyzes the description and picks out the skills and keywords that the hiring manager cares about.
Oh, wow.
Then it suggests ways to use those keywords, making sure your answers match what they're looking for.
It's like a personal assistant helping me craft the perfect response. I can't wait to learn more in our next session. Thanks for all the great advice.
You're very welcome. We covered a lot of ground today.
We did. I'm feeling much more confident about those interview questions. See you in part 2.
Welcome back to your Material Stress Analyst interview deep dive. Ready for more practice questions?
Absolutely. But before we jump in, I remember in RoleCatcher's career guide, they talked about staying updated in this field.
Yes. Continuous learning is key.
Why is that so important for material stress analysts?
Because it's always evolving. New materials, new technologies, new software all the time. They want to see you're committed to keeping up.
So how do I show them that during the interview?
Talk about how you stay current. Mention professional organizations, conferences you attend, journals, online courses, anything that shows you're actively learning.
So like certifications.
Yes. If you have them or are working towards one, definitely mention it, like the Certified Stress Analyst certification.
Okay, so it's about showing them I'm not just standing still, I'm moving forward.
Exactly. Always learning, always growing.
Got it. I'm ready for those questions. Bring them on.
Great. What's question number 11?
All right, here it is. Describe a time you had to solve a complex problem related to material stress. Classic behavioral question.
It is. They're checking out your problem-solving skills, how you think under pressure.
So what kind of situation should I talk about?
A project where you faced a tough problem related to material stress. Explain what made it complex, the steps you took to analyze it, find solutions.
Did I have to collaborate with others? Did I have to get creative?
Exactly. Did you have to think outside the box? Highlight those aspects?
What if I used a structured problem-solving method, like DMAIC? Should I mention that?
Definitely. It shows you have a systematic approach, which interviewers love.
Okay, great. How do I structure my answer to really make an impact?
First, set the scene. Describe the problem, why it was so tricky. Then, walk them through your process, the steps, the tools, the people you worked with.
And then the outcome.
Yes.
Yeah.
Highlight the positive results. Did you save time? Reduce costs? Improve safety? Quantify your achievements whenever possible.
Okay, I'm taking notes. Now, what about follow-up questions? What might they ask?
They could ask about lessons learned or how you'd approach a similar problem differently next time, or how you handle pressure, ambiguity.
Got it. I'll be ready to show off my problem-solving skills.
Sure.
What's next? Question 12. How do you stay updated on the latest advancements and trends in material science and stress analysis? Didn't we kind of cover this already?
We touched on it. Now's your chance to go deeper, give specific examples, talk about conferences you attended, organizations you're a part of, journals you read, online courses you've taken.
So, I could mention being a member of the American Society of Mechanical Engineers, attending their conference on composite materials,
Perfect.
and subscribing to the Journal of Materials Engineering and Performance.
Great examples. It shows you're actively engaged in the field.
Okay, got it. What kind of follow-up questions should I expect?
Specific conferences, presentations you found interesting, key takeaways from articles, or your future learning goals, how you plan to develop certain skills.
So I need to be ready to talk specifics and show I'm truly passionate about learning.
Got it.
Next question. Question 13 is, describe your experience with different types of material testing methods. Sounds pretty hands-on.
It is. Material testing is crucial. They want to know you're familiar with the techniques, the equipment, the results.
So if I've done tensile testing, impact testing, I should definitely talk about those.
Yes. Describe the tests, the equipment, the data analysis, any challenges. Interesting observations.
I remember working on a project where we used a scanning electron microscope to look at a fracture surface after impact testing. It was amazing to see the microscopic details.
That's a great example. It connects theory with real-world observation.
This is so helpful. What follow-up questions might they ask about material testing?
They could ask about specific test standards like ASTM or ISO,
Okay,
or limitations of certain methods, how you'd troubleshoot common problems.
got it. I'll be prepared to dive deep.
Yeah.
Before we move on, can we circle back to RoleCatcher's AI platform? I'm really curious about the interview practice feature.
It's fantastic. Their AI can analyze your responses and give you feedback on content, delivery, even body language.
Like a virtual interview coach.
Exactly. It's personalized to help you refine your responses and presentation.
That's amazing. Okay, back to the questions. Question 14, what is it? How would you approach designing a component to minimize stress concentrations? This sounds like it combines design and stress analysis.
You got it. This gets to the core of the job, using your knowledge to design stronger, more durable things.
They want to see if I can spot those stress concentrations and fix them through smart design choices.
Exactly. Think about different techniques you know. Increasing fillet radii, adding stress-relieving features, optimizing load paths.
And explain the reasoning behind them.
Right. How does each choice minimize stress concentration?
So if they asked me to design a bracket for a heavy load, I'd talk about increasing the fillet radii at the corners, maybe adding a rib to stiffen it and distribute the load better.
Perfect examples. You're demonstrating practical design knowledge.
What about follow-up questions on design and stress concentrations?
Trade-offs in different approaches. How to balance strength, weight, cost, or how you'd use FEA to analyze and optimize the design.
Okay, I'll be ready to explain my choices. This is great.
It's a key part of the job.
Okay, question 15, ready for it.
Yeah, what is it?
How do you ensure the accuracy and reliability of your stress analysis results? This seems to be about being careful, making sure your work is solid.
It is. Stress analysis results are crucial. They want to see you understand quality control, that you have a system for checking your work.
It's not just running the analysis, it's about double-checking, making sure the results make sense.
What are your strategies? Have you ever had to go back and fix something?
Definitely. Once I was analyzing a beam, and the stress was way too high. Turned out I'd used the wrong material properties.
Easy mistake to make, but it highlights why checking your work is so important.
So how do I answer this question effectively?
Emphasize your commitment to accuracy. Then talk about specific strategies. Clear problem statement, proper meshing for FEA, validating results against data or benchmarks, documenting your work.
So show them I'm not just blindly trusting the computer.
Right. Show them you're a critical thinker.
What about follow-up questions on quality control?
Specific validation methods you've used. How you handle discrepancies between analysis and experimental data. Your experience with quality control software or procedures.
Got it. I'll be ready to talk about my process in detail. Before we move on, I remember RoleCatcher mentioned the importance of networking in this field.
They did. Networking is huge. Finding jobs, staying up to date, connecting with others.
So attending conferences, joining organizations, reaching out on LinkedIn.
All great ways to build your network.
Makes sense.
Right.
Okay, ready for question 16.
Let's hear it.
Explain the concept of a factor of safety and how it's used in engineering design. Sounds like it's all about safety and reliability.
Absolutely. It's crucial, especially where failure could be disastrous. Think of a bridge. You wouldn't design it to handle just the expected traffic load. You add a margin for the unexpected, for variations in materials.
So building in extra strength just in case.
Exactly. You're designing for safety. Usually you calculate the factor of safety by dividing the material's ultimate strength by the allowable stress.
And the higher the risk, the higher the factor of safety. Right.
Or a bridge needs a much higher factor of safety than a bookshelf.
Makes sense. So how do I explain this?
Define factor of safety and its purpose. How it's calculated, what factors influence its value, risk, uncertainty, consequences of failure.
Okay, I could give an example. Like a paperclip might have a factor of safety of 2, but a bridge might be 5 or more.
Perfect. Illustrates the point beautifully.
Great. What follow-up questions might they ask?
Situations where a higher or lower factor is needed, or how you determine it for a specific design problem.
Okay, I'll be ready to talk about designing for safety. What's next? Question 17. Describe your experience with using CAD software for stress analysis.
This is about the tools we use, right?
Yes, CAD software is essential. They want to know you're comfortable using it for modeling and analysis.
So not just basic CAD skills, but using it for engineering work.
Right. Highlight your skills with specific software used for stress analysis.
Right.
SolidWorks, Autodesk Inventor, PTC Creo. Talk about creating 3D models, applying loads, running simulations, interpreting results.
So if I use SolidWorks to create a bracket and then ran a simulation on it, I should mention that. Exactly. Be specific about the software and what you did with it.
Okay. What follow-up questions could they ask about CAD and stress analysis?
Specific features, how you'd model certain structures, your experience with stress analysis modules or add-ins, how you validate your CAD-based results.
Okay, I'll be ready to discuss that. Before we move on, RoleCatcher also mentioned soft skills being important.
Yes, technical skills are essential, but so are communication, teamwork, problem solving.
Being able to explain your findings, work with others.
Right. Don't forget to highlight those strengths throughout the interview.
Great point. Okay, question 18. What is it? Describe a situation where you had to make a decision regarding material selection based on limited information. This feels very real world.
It is. Engineers often have to make decisions with incomplete data, tight deadlines. They want to see your judgment, how you think critically in those situations.
It's not just about knowing the right answer. It's about making the best decision with what you have.
Think of a project where you faced this. What information was missing? How did you get what you needed? What factors did you consider?
I could talk about selecting a material for a prototype, but the testing data was incomplete. I could explain how I researched similar materials, talked to colleagues, and considered things like cost and availability to make the best choice.
Excellent example. It shows you can be resourceful and make smart decisions even when things are uncertain.
What follow-up questions could they ask about this?
Your tolerance for ambiguity, how you assess risk, how you prioritize information gathering when time is tight.
Okay, I'll be ready to talk about all of that. This is fantastic preparation.
It is. These behavioral questions can be tough, but practice makes perfect.
Okay, on to question 19. What is it? How would you explain the importance of stress analysis to someone with no technical background? This is about communication.
It is. Being able to explain complex things simply is crucial, especially when you're working with people from different backgrounds.
So translating engineering into plain English?
Exactly. Think analogies, everyday examples. A structure under stress is like a stretched rubber band. Or talk about bridges, airplanes, smartphones, things people use every day.
So I could explain how stress analysis helps make sure bridges can hold the weight of cars or airplane wings can handle the forces of flight?
Perfect. Focus on the why, not the how. People get it when they understand the impact on their lives.
What follow-up questions should I be ready for?
They might ask you to explain a specific concept simply, or for a real-world example of how stress analysis prevented a disaster.
Okay, I'll be ready to explain it like I'm talking to my grandma. Yeah. Before we go to the last question, RoleCatcher emphasized showing passion for material stress analysis during the interview.
Yes, enthusiasm is contagious. Be ready to talk about what excites you about this field. Do you have a particular area of interest? Share it.
Great advice. Okay, last question in this section. Hit me with it. What are your salary expectations for this role? The dreaded salary question.
It can be tricky, but remember, it's a two-way street. They need to know if you fit their budget, and you need to be fairly compensated.
So should I just give them a number?
Do your research. Use websites like Glassdoor or Salary.com to see what's typical for your experience level in your area.
So it's about knowing my worth, but also being realistic about the market.
Exactly. And if you have special certifications or experience, use that to your advantage.
So how do I answer when they ask?
Be ready to discuss your salary range professionally and confidently. If they push for a number, give a range, not a single figure.
A range gives me some flexibility.
Exactly. Room to negotiate.
What follow-up questions might they have about salary?
They might ask about your previous salary or other benefits that are important to you.
Okay, I'll be ready to talk about the whole package. Before we move on, I wanted to thank you for reminding me about the STAR method from RoleCatcher's interview guide.
It's a great way to structure your answers for behavioral questions. Situation, task, action, result. It creates a clear story that highlights your skills.
I've been using it to prepare, and it's really helpful. Okay, what's next?
On to the final part of your prep. More challenging questions, and we'll talk about making the most of those last few minutes of the interview.
I'm feeling ready. Thanks for all the great advice.
Welcome back. It's the final part of your Material Stress Analyst interview deep dive. We've covered a lot, from technical stuff to behavioral questions. Now for some finishing touches.
I'm ready. You know, one thing I've always wondered, in that last part of the interview, when they ask, do you have any questions?
Yeah.
What should I be asking them?
That's a great question. It's not just a formality. It's your chance to see if it's the right fit for you, too.
Okay, so it's like I'm interviewing them now.
Exactly. It shows you're engaged, you're really thinking about this.
So what kind of questions should I ask?
Company culture is always good. Team dynamics, professional development, work-life balance. Get a feel for what it's like to work there day to day.
Okay, so it's about getting a sense of the environment.
Right. And about the role itself. Ask about the key projects, how success is measured, potential growth paths.
Oh, that's smart. Shows I'm thinking long term.
Exactly.
Yeah,
You're
but-
invested in your career.
This is helpful. It's a whole different perspective.
Yeah.
Okay, ready for those last few practice questions?
Let's do it. What's next?
Question 20 is, describe a time you had to work on a team to solve a problem. Teamwork, it's everywhere. But how do I highlight my experience in this field?
Think of a project where you collaborated on something related to material stress or design. What was your role? The challenges? How'd you overcome them? What did you contribute?
Okay, let's say I was on a team designing a lightweight structure for an aircraft using composites. I could talk about doing the stress analysis, how we had to try different designs to meet the weight requirements but still be strong, how my analysis helped find potential weak spots so we could fix them in the design.
Perfect example. You're showing you can work with a team to get things done.
What kind of follow-up should I expect on teamwork?
Your preferred team roles, conflict resolution, how you handled different team dynamics, maybe even a time a project didn't go well and what you learned.
Got it. Show them I'm a team player. Okay, question 21. What are your strengths and weaknesses as a material stress analyst? The strengths and weaknesses question.
It can be tough, but it's about self-awareness. For strengths, highlight what makes you great in this field. Are you amazing with FEA software, problem solving, explaining technical stuff to non-technical people?
Okay, so I can mention my ANS/YS skills, my analytical abilities, and how I can break down complex concepts so anyone can understand.
Those are great strengths. Now for weaknesses, be honest but strategic. Pick something real, but not a deal breaker, and focus on how you're improving.
So like if I'm not as experienced with composite material, I could mention I'm taking a course to get better.
Exactly. It shows you're proactive.
Okay, what kind of follow-ups on strengths and weaknesses?
They might ask for more details, specific examples, or about your career goals and development plans.
Got it. Ready to dive deep. Next question. Question 22. Tell me about a time you had to deal with a difficult client or colleague. Always a bit awkward.
It can be. But it's a chance to show you can handle conflict professionally. Pick a situation where you had to deal with a tough personality or disagreement. Explain what happened, your approach, how you communicated, and the result.
Okay, so if I had a colleague who didn't like my design recommendations to improve the fatigue life of something, I could talk about how I presented my analysis, listened to their concerns, and we found a solution that worked for everyone.
Excellent example. You're showing you can be diplomatic, find win-win solutions.
What kind of follow-ups might they have about this?
Your approach to feedback, mediating conflicts, maintaining boundaries.
Okay, I'll be ready to talk about all of that. Last question. Bring it on. Why are you interested in this particular role at our company? Seems simple, but I want to knock it out of the park.
This is your time to shine. Use your research. Connect your skills and goals to what you know about the company. What excites you about this role at this company? Be specific.
So if it's a company known for sustainable materials, I could talk about my passion for that and wanting to contribute to eco-friendly products. Maybe mention specific projects that interest me.
Perfect. Show them you've done your homework and you're genuinely excited.
What kind of follow-ups could they have?
Your long-term goals, your understanding of their industry, their competitors, their challenges and successes, they want to see you've really thought about this.
Okay, I'll be ready. Wow, this deep dive has been amazing. I feel so much more prepared to answer those tough questions, show off my skills and experience.
You're ready. Remember, confidence is key. Believe in yourself, show your passion, and don't forget all the great resources RoleCatcher offers. Their AI can really give you an edge.
Absolutely. RoleCatcher has been a lifesaver. I'm feeling confident I can ace this interview and get my dream job.
I have no doubt you will. Good luck. We're all rooting for you.
Thanks so much for all the help. This deep dive has been incredible.